In this video, we'll be graphing this rational function 12x squared over 3x plus 5 quantity squared. The first thing we want to find is the vertical asymptotes. That is, where is this function undefined? Let me just sketch a Cartesian coordinate system here. Okay, what is the x value that would make this function undefined? Well, that's going to be where the denominator is 0. We can't let the denominator equal 0. Or in other words, that is where 3x plus 5 equals 0. If that equals 0, then the function is undefined because we have 0 in the denominator. So solving this real quickly, we get x equals negative 5 thirds. So x equals negative 5 thirds. That is at about negative 1 and 2/3, at exactly negative 1 and 2/3. So I'm going to draw our asymptote. This blue dashed line is not part of the graph of this function. It's just a vertical asymptote that says we know that the graph will not cross this line. Now you can plot a few points. You can plug in some points in for some values in for x. Maybe negative 2 and then negative 5 and so on to see what this graph looks like, and you'll find that it looks like this. It shoots way up as you get really close to negative 5 thirds, and as you go farther to the left it just goes out lower and lower. Okay, this is a rough sketch, of course. Now, where are the x-intercepts? That is, what values of x make this function equal to 0? Well, that's where the numerator equals 0. So that the values where we will find the x-intercepts are where the numerator equals 0. 12x squared equals 0. Well, that's an easy one to solve. X equals 0. So we know that this graph is going to cross at x equals 0. I'm going to switch to green now. You could plot some points again in between 0 and negative 5 thirds to see whether this shoots down or shoots up. And I'll cut to the chase. It shoots up, so we're coming down like this. We know that it touches or crosses or touches the x-axis when x equals 0. And then you can plot some more points over here to see if it goes down below the axis or goes back up. Well, it turns out that it does go back up, but then does it go up high or does it stay low? Well, the way you find that is the horizontal asymptote. And the horizontal asymptote is found by the ratio of the leading coefficients. So if we were to square this denominator, I'm just going to square the denominator here. 3x plus 5 times 3x plus 5, you get 9x squared plus, let's see, 30x plus 25. Okay, so what you have is you have x squared and x squared. So as x grows very large, you've got x squared in the numerator and x squared in the denominator. As x grows very large, positively or negatively, the rest of this stuff is negligible. It doesn't add much. You're just looking at the x squareds. Those just blow up. And then furthermore, those you could kind of think of those as canceling each other out, and then you're just left with the ratio of the leading coefficients, 12 to 9. So the horizontal asymptote is going to be y equals 12 over 9. Or in other words, y equals, reducing this fraction, 4 thirds. So this is just going to come up a little bit. Never go above 4 thirds. All right. So that is graphing this rational function. I hope that helped.